All right, in the last video, we handled collisions in the horizontal plane. This time, we're going to handle collisions if the ball is traveling up and it is collided in the y direction, up or down. We're going to handle those collisions. And so this is the vertical. I'm still working in the check collisions method. This is just underneath the, so we have calculate corners or check collisions. This is the check collisions method. We're still working on that. And we have done the horizontal collisions, which lasted all the way down to here. And now we're going to do the vertical collisions. And so we need to calculate the corners now. If you remember the last time, we looked forward in time, one frame of animation in the X direction. This time, we need to look forward one frame of animation in the Y direction. Oops, calculate corners based on the current X position, the Y destination, where we're headed, and also whatever rectangle we're checking. So now, all of the values of top left, top right, bottom left, bottom right have been calculated based on the current X position, the future Y position, and whatever rectangle we're checking it against. And this rectangle is going to represent either the brick or the paddle that we're checking. So now we need to finish this out. Well, we've got the values here. So we're going to say if we're going up or if we're going down, let's do that one first. Going down. Now, so to indicate that we're going down, if dy is greater than 0, we're headed down. In that case, if the bottom of the circle has collided, so if bottom left or bottom right is true, if either of those things has overlapped with whatever rectangle we're checking, we're going to flip the value of dy, so we're going to bounce the ball back in the opposite direction in the y direction. We're going to indicate that a collision has been detected, and we're going to set the position of the ball slightly off to the top of the rectangle, equals the integer value, the integer component of the r.getMinY, so the top of the rectangle, minus the radius of the ball, which is the diameter or the size divided by 2, and minus 1, just to make sure it's scooched all the way off to the side. Now we have to do the going up part. So that was the if the ball is traveling down and it has collided with something, but now we're going to check if dy is less than 0, so if the ball is headed up, so going up. Now we need to check the top, if the top of our ball has come in contact with the rectangle. So if top right corner or bottom or top left corner has a value of true, if either of those corners has collided with the rectangle, then we're going to again flip the value of dy so that we bounce it. The ball goes in the opposite direction. We're going to indicate that a collision has happened by flipping the value of this Boolean to true. And we're going to set the temporary position in the y direction to the integer or whole number component of the rectangle's max y, so the bottom of the rectangle, because it's collided going up, right, plus the ball size or the diameter divided by 2, so that's the radius, plus 1. So in this case, right, the ball is headed up. So dy is negative, so it's going up. And if while the ball is going up, the top right or top left corner has hit something, then we're going to bounce it down. We're going to say that a collision has happened. and we're going to scooch the ball off to the bottom side of whatever rectangle it has come in contact with. Now, I know that's a lot of information, and it takes a little while to wrap your head around what's actually happening in a collisions detection method. So you can either choose to really spend some time and understand it, or you can just sort of make sure you're copying things down correctly. Either is fine at this point. This is a complicated algorithm to determine what to do in the case of a ball or any object, two rectangles colliding with each other. So that is the complete collision detected method. In the next one, in the next video, we're actually going to put it to use and start so that you can actually see the ball does bounce off the paddle once we get these things all up and running.